today. Okay, if you guys were to look at your canvas, it looks like this. Okay, you'll look on week 3. Okay, today you should have tautology and contradiction assignment done. That's exercise 11. It should be done today. Okay, so our TAs will check that and study all day, and they'll get it in our grade book. The implications assignment is due tomorrow. The theorems of logic and arguments assignment, that'll be due Thursday. Okay? It'll be due Thursday. It doesn't say Thursday out right now because I didn't save it when I did it. So that assignment will be due Thursday, and you have a quiz on Thursday as well. Okay, questions? Yes?
If we can't get on the canvas, how do we know how we got in the exam? What we got in the exam?
I'm going to give them back to you to let them look at the end of class if you get through everything. If not, we'll go through tomorrow. Okay? So Canvas, yes, you can get on. If you can get an internet connection somewhere, you can get on the Canvas and look. Study hall, you can get on and look at your final exam score as well. If you scored below a set, not the final exam, if you scored below a 70 on the exam, then you need to get corrections done. Like you don't have an option whether you want to or not. You need to get corrections done if you want to pass SU prep. Does that make sense? So it's like if you got below 70, you need to get corrections done. TAs, you guys have correction papers then?
No.
You got the email I sent last week? You got it? You print some out so they can do them?
Yeah.
And then, so on the exam, okay, I'm going to be very clear on this. Okay, I tried to tell some of you before, but some of you didn't listen. Those who did well on the definition part of the exam did well on the rest of the exam. Okay, there's a very strong correlation to the people who did really well on the first 2 pages. But there's like 18 definitions that you guys, or 14 definitions you guys went over on the first 2 pages. Those of you that studied the definitions and understood the definitions did very well on the rest of the exam. And most people were either, I had quite a few people in the 90s, got a couple people in the 80s, and like a couple people in the 70s, and then the rest of you were 50 or below. But people who got 50s in the 50s and below, you guys didn't do well on the vocabulary. So the vocabulary is crucial to the rest of it. So make sure you get the vocabulary down and you understand what you're doing with the vocabulary. And you'll, like I said, people that did well with the vocabulary, they did well on the rest of the exam. Yes?
Were there any hundreds?
Yes. There were, I think, 100 and several in the 90s. Several in the 90s. Yes?
When are we going to be able to look at our exams?
Hopefully at the end of class. So, actually we can't until other people haven't taken it. So when those people take it, we can look at it. So we gotta get people to take it first. So I can't hand it back to them. And then you guys don't keep the exams either. So let's get moving on this. We're going to go to implications today. Implications is the page you need to be on. It's titled Implications. So you guys are supposed to finish exercise 11. Let's review real quick. What is a tautology? What has to happen in this box to make the 2 statements a tautology? So, what has to happen? Yes?
On the last boxes, they all have to be true.
Okay, the boxes have to be true. What do you mean?
Like, so the last couple of boxes on the very last line, they would all be true to make it a tautology.
Okay, let's look at the definition of tautology and see if you're right. So tautology is an if and only if. So a statement is a tautology if and only if it is always true. So no matter what, if I have, and it doesn't have to be just this box. So you're right, they all have to be true. In this case, this statement is a tautology. But if this one was all true through here, it would also be a tautology. Because remember, each column represents a statement, right? Each column represents a statement. So if the whole column is true, it's a tautology. If the whole column is false, what is it?
Contradiction.
Contradiction, very good. Okay. Implications. Oh, almost done. Okay. Who, definition 13, who read for us? Go for it.
Let P, Q be any two statements. P implies Q if only if P then Q is a tautology. From theorem 1 stated before, we notice this also means P implies Q if and only if P or Q is equal to Q.
Logical equivalent, good, good. Okay, very good. Thank you for reading that. So, let P and Q be any two statements. Any two statements, okay? So this happens for any two statements. If you have a P value and a Q value, okay, P implies Q if and only if P, if P then Q, the conditional statement, if the conditional statement, if P then Q is a tautology. Right?
How can if P then Q then be a tautology?
So if this statement's a tautology,
Yeah, I get that part, but how can that statement be a tautology? If it's true then false, if it's false then how can it be a tautology?
we'll get to it in just a second. Is that okay? Okay. So, this is what we have to assume. So when we see the word let, that's what we're saying. This is set in stone. This is what's going to happen. Let P and Q be these two statements, if and only if P then Q is a tautology. So, from theorem 1 stated before, we notice this also means P implies Q if and only if the disjunction of P and Q is logically equivalent to Q. Okay? So, think about the definition for a second. It's not very clear yet. We're going to apply it and it'll start to make more sense here. So now, notation. So we have this arrow here. So this is read as P implies Q. Okay? This little arrow, P implies Q. Okay? P implies Q. Then we have P does not imply Q. So look at example 15. Yeah, let's look at example 15. We'll see what we mean here. Consider the following statements. The animal is a beagle. So we have an animal. The animal is a beagle. The animal is a dog. So then the expression P implies Q can be written as the animal is a beagle implies the animal is a dog. And if we rewrite it as if P then Q, it becomes if the animal is a beagle, then the animal is a dog. So notice the difference between the arrows. Okay, we got fat arrow and skinny arrow. Okay? The fat arrow means implies. Okay? It's got some space between it. It implies. So the animal is a beagle implies the animal is a dog. But if we write it as a conditional statement, if the animal is a beagle, then the animal is a dog. We then need to show the statement is a tautology. That is, the only time the statement is false is if the antecedent, the animal is a beagle, is true, and the consequent, the animal is a dog, is false. So the only time that it is false is if this statement, if the antecedent, the animal is a beagle, is true, and the consequent is false. So we're setting up an idea right now. Has everyone got the idea set up in their head? We're taking an implication. This is our implication. Then we have a conditional statement from the implication. And now we're going to keep going with that idea. Okay? If P implies Q, okay, if P implies Q, we say that Q follows from P, because Q is after P, right? So it follows from P. Q follows from P, or that Q is derived from P. The conditional statement of if P then Q, okay, is a relation between statements P and Q. So we've got an implication and a conditional statement. Maggie, can you look up here for a little bit? Ladies in the back, what's going on? We paying attention? Okay. So this relation is called an implication. It should not be confused with the conditional statement if P then Q, which is a new statement made from statements P and Q. So the implication, we get a conditional statement from the implication. Okay, so connect those two ideas right now. We got our implication, got a conditional statement.
So they're not the same thing.
No, but we're going to see how they connect.
Okay.
Okay? So on 16, so we're going to prove the relationship right here. So we've got the conditional statement of if P then Q as a conjunction with not Q implies not P. So this whole statement, again, the conditional statement of if P then Q as a conjunction with not Q implies not P. So to prove this, we want to show that this statement, okay, this implies not P. That's what we want to show. So to do that, we've got to show that this statement, as a conditional statement with not P, is all a tautology. Okay? So to prove this, we show that if P, then Q, as a conjunction with not Q, as a conditional statement with not P, is a tautology. So notice the difference here. Give me 1 second, okay? So if we go back to the Beagle one, if we were to prove these, okay, this is our implication. We can rewrite it as this. And then we would show that the conditional statement of if P then Q, we could show it as a tautology. Now what we're going to do, we're going to actually show it with a different statement. Down here. Okay, we're going to look at 16. So, to show this, you got to show our P and Q. Okay, notice, okay, this is something other people screwed up on the test and it screwed you up on a question, okay? So some of you, if you just get this pattern down, if you have two statements, if you start with two statements, P and Q, all we have is P's and Q's here, right? Everyone see that? So if you're asked to make a truth table and you only have P and Q to start with, do a true, 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 false, false, true, false, false. Some of you guys did like true, false up here, false, true here, false, false here, and a true, true here. That's fine, but if we just have the pattern down, it helps a lot of you to say, oh yeah, I know what this is supposed to look like to begin with. Okay? You can do it in other patterns here. You can do a true, false, false, true. As long as you have all four of these situations, it's fine, but then you got to match this up right. I always just like to start with a true, 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 false, false, true, false, false, just like our notes. Some of you did that, some of you did not, and it messed up some of you because you kind of had stuff all over the place on the exam. So if we have a true, true, and then we have a false, false, that makes the conditional statement true, which here, the conditional statement is true with a not Q, which a true, false would be false for our conjunction, right? And then we take a false conjunction with a false P, that's going to be true.
Yeah, because it's a conditional statement.
Yes, this is a conditional statement. So this is not an implication, this is conditional. So if we show that the conditional is a tautology, okay, which is what that table shows, then we know that P does imply Q. Because P implies Q if and only if the conditional statement of P and Q is a tautology. So if the conditional statement is a tautology, then P implies Q. Right? You see what I'm saying? So if you have P implies Q, to make sure that P implies Q, you make sure that the conditional statement of P and Q is a tautology. So that's what we're checking here, is all we're doing with this truth table is that we're just making sure that if we take this implication that they gave us, you guys look on your paper, sorry, this is kind of on the, get it down just a little bit. We take this implication, they're saying, hey look, prove this relationship, make sure it's an implication. So you're going to say, make sure this is an implication. That's the whole goal of this question in example 16. Example 16 says, hey, make sure it's an implication by proving it. To prove that it's an implication, we show that the conditional statement is a tautology. Because that's the rule. If that conditional statement's a tautology, then this is an implication. Because the only way this can be an implication is if this conditional statement's a tautology. Okay, question?
Can we use the big arrow and the little arrow interchangeably?
Processing.
No.
Process.
No. That would not work.
Wrong.
The only way we can show that this is an implication is if this is this conditional statement's a tautology.
Okay.
So it's not always going to be, it's not commutative basically, is what you're kind of getting at, right? We can't just switch out the signs. They're not the same sign. Good question. Okay, so if you guys look at this, you guys should be able to fill out a truth table pretty well by now. Okay, this truth table is not anything new. This is something from the exam. You just have to know what your conjunctions mean. When is a conjunction true? When is a conjunction true? Yes.
When all the statements are true.
When all the statements are true. Look here. If we have this statement has a conjunction with this statement, it's true. All other cases, the conjunction's false. So the only time a conjunction is true is when?
When it's all true.
When they're all true. Okay? When is a disjunction true? When is a disjunction true, Violet?
When there's
One or more true. Okay, when is a disjunction false? A disjunction false. Yes? When they're both false, right? When neither statements are true. Good. Okay. Okay, what we're going to do now is we're going to do your seating chart. Okay, get your stuff ready to move. And then we're going to do the exercise after this. Okay, this is when I call your name, this is how it's going to work. Okay, the first name I call. Okay, listen so you know where you're going. The first name I call will be this inside desk. Then we'll go 4 chairs. Then we'll go to the next row, 4 chairs. Then the next row, 4 chairs. Then the next row, 3 chairs. After that back row is filled, then we're going to have this row, 4 chairs. This row, 4 chairs. And the next row, 4 chairs. Okay? Everyone got it? Yes, 4 in. But we're starting here. We're going to go 4 in that way, 4 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 that way. Okay? So in the first